Yes, so this session uh, will deal the game theory. You know the meaning of a game. Game means a play between two players or two teams or two companies competing for maximizing their sales. So any two players when they involve in the game, it's called a two-person game. And more than two players can also be there playing a game. If there are more than two players playing a game, it's called a n-person game. If there are only two players playing the game, it's called a two-person game. And two-person and if the sum of the amount that has been gained by one player is equal to the amount that has been lost by another player, it is called zero sum game or constant sum game. Now, game consists of a set of rules to be followed by both the players, player A, player B, or team A, team B, or company A, company B. Certain rules must be followed while playing a game, and each player shall have his own strategies. Suppose, say, two cricket teams are playing a game. Team A, call it as an Indian team, say it's an Indian team. It has its own strategies. What do you call to play a game? First 5 overs, let it be what you call bowled by the spinners. Maybe the course of action one, or say strategy one. First 5 overs, let the fast bowlers, bowl. Second, second is one. Then third strategy, maybe mixing the fast bowler and the spin bowler. Third strategy, like that. Now, n number of strategies for each player to maximize the benefits in respect of maximizing play, to minimize the losses in respect of minimizing play. While playing a game, I'm sure there will be one player maximizing player and another is the minimizing player. The objective of minimizing player is to minimize his losses at the end of the play. The objective of maximizing player is to maximize the gains. So now game theory consists of the knowledge which provides the players the best strategies. What is the strategy with which each player can play for maximizing the benefits? That will be what is the value of the game? What is the value of the game? What are the best strategies available for the players? There may be n different strategies for each player, and the objective of the game theory, the objective of what do you call this game theory models, is to find the value of the game and the best strategies available for each player. So there are different game theory models basing on the number of persons involved in the game, number of strategies involved there, number of strategies that each player has, and depending upon the size of the game. I will tell you what is a game. Game is expressed in terms of the payoff matrix. I will tell you. So this theory you can go through this one. Play means a play of the game results when each player has chosen a course of action. Course of action is nothing but strategy. From the different courses of action, from different course of action or strategies available, a player has to choose one particular strategy to play a game. Player means each party or each team is called a player. And what is this called? Two-person zero-sum game. I told you already, when there are two players playing the game, it is called two-person game. Instead, if more than two players are involved in the game, it is called a n-person game. N may be greater than 2. If it is n greater than 2, it's called n-person game. And if the games can also be what do you call classified the other way. If the sum of the amounts won by all winners, suppose if there are n players involved in the game, some will be winners and some will be losers. Some players will be winners, some players will be losers. Playing cards, say. Playing cards is also a game. Few people will be winning some certain amounts at the end of the game. A few people will be losing. So sum of the amounts won by all winners is equal to the sum of the amounts lost by all the losers. And the game is called zero sum game or it's called constant sum game. When two competing firms compete for market share, market gain of one firm will be equal to market loss of another firm. But if two firms effectively involve in intensifying advertising campaign, then the sales of both may increase and their share in the total gain need not be equal. So in all the situations, the amount lost by one player is not equal to the amount gained by another player, any player. So in certain cases it's possible, in certain cases it's not measurable that way. It will be different. So 2% zero-sum games are called rectangular games because their payoff matrix is in the rectangular form. Game will also be expressed. Game always will be expressed in the form of a matrix. I will tell you what is the payoff matrix. So before we actually go for that one, I just would like to what do you call elaborate what is meant by a strategy. Strategy means a particular course of action. I told you. So first 5 overs, let only spinners will bowl. Strategy one. First 5 overs, let only fast bowlers will play, depending upon the opponent's team strength, batting strength, say, or mixing spinner and the fast bowler. The third strategy like that. So there may be different strategies for the teams. So it is what you mean by strategy. It's a predetermined rule by which a player decides a course of action from his own alternative course of action. There may be different strategies from which he will be choosing one strategy to play a game. He cannot play a game simultaneously with all the strategies, remember. He will play a game at any instance, he will be playing with one particular strategy only, remember, this one. And there are two types of strategies, pure strategy and uh, the mixed strategy. Pure strategy means from all the available courses of action, from all the available strategies, a player can choose one strategy as the best strategy. It is possible by solving the game theory model. If a pure strategy is available, that can be known by solving the model. Only one strategy among all the alternative strategies, there is only one best strategy for the player, for each player. Let player A has three strategies, player B has three strategies. A will have definitely one pure strategy. B will have one pure strategy, one best strategy. If at all both the players have only one best strategy, one best strategy for him, one best strategy for the other player. If that is the case, that is called a pure strategy game. Instead, it may not be possible to select a particular strategy. It may not be possible in certain games to tell the player, this is the best strategy for you, this is the best strategy for you. It may not be possible by solving the model. It's not possible to advise the players what is the best strategy for the player A and what is the best strategy for the player B. So in that case, you can give certain what is what will be advised there. You can give the solution to the players. 80% of the time, you can tell certain probability distribution with which he can choose the strategies. He can choose more than one strategy. He will be playing with more than one strategy. I mean to say, 80% of the time he will play with the first strategy. 20% of the time he will play with the second strategy. Or player B, 70% of the time he will play with first strategy. 20% of the time he will play with second strategy. 10% of the time he will play with third strategy. And if it all has fourth strategy, he will never choose fourth strategy. So that way, if you if it is possible to what you call express the probability distribution or find the probability distribution with which he is going to choose the available strategies, then that is called the mixed strategy game. Each player cannot play with one particular best strategy in certain games. That's not possible. They are called mixed strategy games. They are called mixed strategy games. In respect of mixed strategy games, player will never play with only one strategy. They will be playing with more than one strategy. How? 80% of the time, or certain 70% of the time, we'll play with one strategy. 20% of the time, we'll play with another. That way, you can express probability distribution with which he's going to choose the strategies and play the game. That's why games are mixed strategy games. You'll have to choose, you'll have to, by solving the model, there are certain criteria to be applied to the payoff matrix to find out whether it is the pure strategy game or a mixed strategy game. If it's a pure strategy game, you can advise each player what is the best strategy for each player. For you, among all the available strategies, this is the best. This one for the player B also you can advise one best strategy. If it's a mixed strategy game, you will be expressing, you will giving the probability distribution to each player, probability distribution of selection of the strategies, available strategies. That will be possible. So payoff matrix I told you, payoff means if player A plays with one particular strategy, player B plays with counter strategy, one counter strategy. Say this one. Assume that player A is having two strategies, call them as the A1 and A2. Similarly, player B is having B1, B2, B3. Three strategies are there for the player B. If A chooses and play with A1 strategy, B chooses with the B1 strategy and play the game, then payoff element will be 26. So given in the problem, or by the description, if at all description is given, problem is given, you'll have to read the problem and find out. Yes, for player A's A1 strategy, for player B's B1 strategy, what will be the payoff? That will be given in the problem. So 26, which means that plus 26. Plus 26 indicates that that is the gain to the player A. So here, if you write player A, this is called payoff matrix for the player A. If you write here player B instead of A, this becomes the payoff matrix for the player B. So that will not be from this. We will follow the convention like this. Here we always write player A. His strategies will be depicted here. Player B will write here, and his strategies will be depicted here. Any number of strategies may be there. B1, B2, B3, Bn and so on. B4, A1, A2, A3 and so on. So like that, A may have different strategies, B may have different strategies. I told you. If A chooses A1 strategy, B plays with counter strategy B1. At the intersection, you find an element called payoff element. This is the outcome. Outcome means after playing the game, what is the result? 26 plus sign is there, which means that the 26 rupees is the gain to the player A and a loss to the player B. Similarly, player A plays the A1 strategy, player B plays the B2 strategy, payoff element is 36, which means that 36 rupees is the gain to the player A, 36 rupees is the loss to the player B. Similarly, if A plays with the A1 strategy, B plays with the B3 strategy plus 8, which means that 8 rupees is the payoff, outcome, that is the gain to the player A, loss to the player B. Similarly, if A plays with the A2 strategy, player B plays with the B1 strategy, this is the payoff element, which means that this is plus to him, minus to this one, that is loss to the player B. So in the payoff matrix, plus indicates, plus payoff elements indicate they are the gains to the player. If at all if any negative element is there here, which means that that is the loss to this player and gain to that player. There are no negative elements in this example payoff matrix. Okay. So once the payoff matrix, so game means from here afterwards, remember, game means the payoff matrix. Game is described as a payoff matrix. Lengthy description, rules and all will be there, and available course of action for each player will be no available courses available. For each combination of the strategies, if they play, what will be the outcome? That will also be given in the problem, either in the descriptive format or directly in the form of payoff matrix. So once the payoff matrix is known, is given, you need to find the you need to find the uh, the solution for the games. Remember, if at all a payoff matrix is given, directly given, the first step you need to do is whether the game is a pure strategy game or not. That must be found out. Pure strategy game or not, that must be found out. So that is possible. See here, the same game is there available here. Same game. Player A has A1, A2 strategy. Player B has B1, B2, B3 strategy. Solution of this is a pure strategy game that can be proved now as a pure strategy game or mixed strategy game that can by applying certain criterion called maxi-mini and minimax criterion. So the criterion will be explained like this. Step 1, find the maximum value for the maximizing player. Find the minimum payoff in each row. See here, Very simple. In each row contains pair of elements. What is the minimum in the row? First row. Minimum in the first row is 8. You can encircle it. You can circle it. 8. In the second row, minimum is 30, 20, 16. Minimum is 16. So first row minimum is 8. Second row minimum is 16. So of the two rows minima, 8, 16, what is maxima? That is called maximini. Maximum of 8, 16 is 16. That is called maximini. Maximini. Just remember that one. Maximini is 16. Similarly, column wise, if you see, column wise, each column you identify the maximum value instead of minimum value. రోల్లో అయితే మినిమం చూసుకుంటాం, కాలమ్స్లో అయితే maximum తీసుకుంటాం. So this column maximum 30, square it. This column maximum 36, square it. This column maximum 16, square it. So of all these maxima of the columns, 30, 36, 16, 30, 36, 16. These are the maximas of the columns. Minimum of this maxima is called the minimax. That is nothing but 16. So earlier maximini was found out, that was 16. Now minimax was found out, that is also 16. If maximini is equal to minimax, we can say that it is pure strategic game. This particular point, this particular value is called the value of the game. Value of the game. This is called the saddle point. Saddle point. Saddle point means player A is A2, player B is B3. Intersection. This is the saddle point. Saddle point means intersection of the 16 is the value of the game now. Minimax equal to maximini. 16 is arrived. And corresponding strategies of player A is A2. Corresponding strategy of player B is B3. This particular point is called the saddle point. And what is saddle point? So what is the best strategy for the pure strategy for player A? A2. So player A should always play with one best strategy, that's called A2. For him, best strategy is A2. For B, best strategy is B3. So this can also be just found out the same algorithm, procedure, step by step procedure there. You need to write the steps also when the simple problem of this kind is given, you need to write the steps also. Very important. Go through the steps. Very important. Saddle point will be found out. So A's best strategy is A2, B's best strategy is B3, and the value of the game is 16. That is the solution for the game. So this can also be just very simple, in a simple way you can find out. First row minimum is 8, circle it. Second row minimum is 16, circle it. First column low maximum 30, square it. Second column low maximum value 36, square it. And in the third column maximum value, square it. So circle was there at the cell as also square is there for it. So when circle coincides with the square, that is nothing but the saddle point. If circle is not coinciding with the square at any position, it is not a saddle point game. It is not a saddle point game. It is not a pure strategy game. This itself, if at all saddle point is there, there is the solution. Solution is nothing but what is the best strategy for the player A, A2, best strategy for the player B3. Value of the game is 16. If he plays with his best pure strategy A2, if he plays with his best strategy B3, value of the game will be 16. That means 16 rupees will always be the gain to the player A on the average. Series of games, if they play, player A will always choose with A2, player B will always choose with B3. And this all data, initial data given is based on the history. So that's about pure strategy games, solution for the pure strategy games using maxi, mini, minimax criterion. That's about this. Then same thing. First row minimum is this, circle it. Second row minimum is circle it. First column maximum 30, second column maximum 36, third column maximum is. So circle coincides with the square, and this point has become the saddle point. This corresponds to A2 strategy of player A, corresponds to B3 strategy of the player B. So player A's best pure strategy is A2, player B's best strategy is B3. Value of the game equal to 16 units. That's about this. Then suppose if the given game is just 2 by 2 size matrix. Suppose for if it is 2 by 2, any size of matrix of C, you can test it first of all whether maxi-mini is equal to minimax. And then, and let us just go through the rules of dominance. First of all, the big size payoff matrix, a big game is given like this. Big game is given like this. Suppose if this is a big game given, A is having 1, 2, 3, 4. 4 strategies are there. B is having his own strategies 1, 2, 3, 4, 5. Player B has 5 strategies. Player A has 4 strategies. His strategies are different. His strategies are different. And for each combination of the strategies, A key, if A chooses first strategy, B chooses first strategy and play +1. If A chooses first strategy, B chooses second strategy +3. And this is how. Okay. And all these elements are plus only now in this particular problem given. Positive, this pair of matrix consists of only positive pair of elements. And the size of the matrix you see, it's a bigger one. First of all, if any bigger size matrix is given like this, you can apply the rules of dominance so as to reduce the size of the matrix to the minimal level. Then you can go for a maxi mini max criterion. Or directly also you can go through that, and if at all games can be solved, if at all if there is no saddle point, there are other methods. So first of all, we do not know whether the saddle point exists for this game or not. First of all, you should come to know if the big size payoff matrix is given, how to reduce the payoff matrix by applying the rules of dominance. So here you see, this is yes. If B follows 1, 2, 3, 4, 5, any strategy as a matter of fact varying from 1 to 5, payoff elements, positives, gains to the player A are given in the first row if he plays with the first strategy 1, 3, 2, 4. Suppose in all the varying conditions, assume that B is going to play with all these strategies. If any row apart from the first row, if any row contains better elements than this, and more elements than this, compared to 1, 3 is better. 3 compared to 3, 4 is better. But compared to 2, 1 is not better. So like that, if each and every element of a particular row is less than or equal to the corresponding elements of another row, then the player A will never choose the strategy that is containing the lesser pair of elements, isn't it? 1, 3, 2, 7, 4. 3, 4, 1, 5, 6. 6, 5, 7, 6, 5. 2, 0, 6, 3, 1. So what it says, first see here. All the elements of the fourth row are less than or equal to the corresponding elements of third row. Fourth row, first row, fourth row. What is it? What is it? This one. All the elements of fourth row are less than or equal to corresponding third, the third and fourth. See, third and fourth. So this, compare this with this. 6 is compared with 2, 5 is compared with 0, 7 is compared with 6, 6 is compared with 3, 5 is compared. All the elements, pair of elements of third row are greater than or equal to the corresponding elements of the fourth row. అంటే third strategy appears to be dominant for him. If he chooses third strategy, more positive values are there, more gains will be there for the player A. In all the varying conditions, player A, player B, assume that player B will play from first strategy to fifth strategy. Whatever is the strategy is going to play from first to 5. All the elements of third row, 6, 5, 7, 6, 5 are greater than or equal to corresponding elements of this row. 6 greater than 2, 5 greater than 0, 7 greater than 6, 6 greater than 3, 5 greater than 1. Hence, A's fourth strategy can be deleted. That's what it says. So it says, if all the elements in a row, say the ith row of payoff matrix, are less than or equal to the corresponding elements of the other row, jth row, then the player A will always choose the jth strategy and ith row can be deleted from the matrix. So rows చూసినప్పుడు lesser elements in a row తీసేయచ్చు. That is what is called rule 1. Rule 1. So game will be reduced. Game size will be reduced to this size. To fourth strategy ఉండదు ఇంకా. If you see any row now is dominating. Studying second and fourth columns, ఇప్పుడు ఏ row కూడా dominate చేయట్లేదు. 3, 4, 1 ఇక్కడ తగ్గిపోయింది మళ్ళీ. 3 greater than 1. 4 greater than 3, 1 less than 2. సో ఇక్కడ ఏది డామినేట్ చేయొచ్చు. ఇక్కడ 6 కంపేర్డ్ ఇది చూస్తే 6 greater than 1, 5 greater than 3, 7 greater than 2, 6 not greater than 7. So no row is dominating. Now consider the columns. So in all the varying conditions of the game, think about the player B. What will be the thinking of B? Assume that A is going to play with all his available strategies 1, 2, 3. B will minimize his losses. After all, B is the minimizing player. B is a minimizing player. You would like to minimize his losses. He will retain what are these values? 3, 4, 5 and 2 1s, and these are the lasts to the player B. So any column which contains larger values compared to the corresponding elements of the other strategy in the column, then larger column can be deleted, and the column which contains larger pair of elements will be deleted. Why? Because he is going to lose the large way in a large way if he plays with that strategy. See here, any column contains lesser elements compared to the other column. That you see. See here, studying second and fourth columns. Second and fourth columns. Second and fourth. 3 less than 7, 4 less than 5, 5 less than 6. Each and every element in the second column less than or equal to the corresponding elements of fourth column. These are the bigger losses for the player B compared to these losses. Hence, he will never choose the fourth strategy. Hence, fourth column will be deleted. This is rule 2. See here. All the elements of column or column of matrix are greater than or equal to the corresponding elements of the column. Say is the column, then the player B will prefer yes the strategy and keeping in view of the player B, or the strategy can be deleted from his list. So player A అంటే రోస్ అంటే maximum ఎలిమెంట్స్ ఉన్న రోని ఉంచుకుంటారు, లెసర్ ఎలిమెంట్స్ ఉన్న రోని తీసేస్తారు. దట్ ఈస్ రూల్ 1. కాలమ్స్ చూస్తే లార్జర్ వాల్యూస్ ఉన్న పే ఆఫ్ ఎలిమెంట్స్ ఉన్న కాలమ్ని తీసేస్తారు, లెసర్ వాల్యూస్ ఉన్న కాలమ్ ఉంచుకుంటారు. దట్ ది సెకండ్ రూల్. సో అకార్డింగ్లీ, so the game is now transformed like this. Here something is deleted. So here third is compared with what is compared? Fourth strategy. Player B will not choose fourth strategy. Fourth is compared with third. Second and fourth. So 3, 4, 5, 7, 5, 6. Hence, fourth column will be deleted. So when the fourth column deleted, game will be pair of matrix will be reduced to this size. Fourth column తీసేస్తే game will appear like this. Pair of matrix will appear like this. Fourth column elements greater than అందుకని తీసేసారు. Then once again 1, 2, 3, 4. Then we compare చేస్తారు. Fourth column elements అదైపోయింది. Second row elements మళ్ళీ row వచ్చింది. One more has to be deleted. 3, 4. Fourth is deleted. Fifth one can also be deleted. Compared to this one, you see, compared to this one, second and fifth strategy. 3 less than 4, 4 less than 6, 5 less than or equal to 5. Hence, for B it will be a burden. Fifth strategy is a burden. Hence, fifth column is also deleted. When fifth column is also deleted, applying the second rule, this will be the game. Now here rows children. You see the rows here. First row 1 less than 3, 3 less than 4, 3 less than 6, 1 less than 6, 3 less than 5, 2 less than 11. Second row elements less than or equal to corresponding elements of third. 3 less than 6, 4 less than 5, 1 less than 7. So 3, 4, 1 అనేది lesser elements. In all the varying conditions of the play by B, A feel that third strategy will be dominating compared to second strategy. Hence, second strategy is removed. Second row is deleted. So, ఇది వచ్చింది. This you got. So, any column now from this, any column is dominating. So, lesser values column will be dominating. Lesser values ఎక్కడ ఉన్నాయి? 1 3 this one, see, 3 average తీసుకో, average తీసుకో. 1 plus 3 average 2, 6 plus 5, yes, 1 plus 3, 1 plus 3 average 2, 6 plus 5 average 5.5. So ఇక్కడ 2 is less than or equal to 2, ఇక్కడ 5.5 is less than or equal to 7. Hence the average of these two strategies are better than this third column. 1 plus 3 by 2, 2. 6 plus 5 divided by 2, 5.5. So ఇక్కడ ఏమొచ్చింది, ఈ average of these two columns 2, ఇక్కడ this one, average of two columns ఇక్కడ 2, ఇక్కడ 5.5, 2, 2, 2, 5.5, 2 is equal to 2, 5.5 less than 2, less than 7. So these values, average values of 1 and 2 are better for player B compared to this column. Hence this column, third column, can be deleted. Hence third rule is applied here. So third rule says that if the average of any two columns dominate over another column, then also you can delete the latter column. So applying that one, this column is deleted. 1 3 6 5 will be remaining. 1 3 6 5, 1 3 6 5 will be remaining. 1 3 6 5 will be remaining. See, game is now reduced to 2 by 2 size. By applying the rules of dominance, large size payoff matrix can be reduced to the dam minimum. Once it is reduced to the dam minimum, you can check whether it contains the saddle point or not. Big size matrix if given, better reduce it by applying rules of dominance, and then find whether it is a pure strategy game or not. So first row minimum, circle it. Second row minimum, circle it. First column maximum, square it. Square it. Second column maximum 5. First row minimum 1 no. Second row minimum 5. Of these row minima, maximum value is 5. ఇక్కడ కాలం maximum 6, ఈ కాలం maximum 5. కాలం maximas ఇవి. Minimum of maxima 5. ఇక్కడ 5, అక్కడ 5. Minimax is equal to maximum. Cycle coincides with this one. So row minimas are always encircled. Column maximas are always squared. If that is the case, coincidence exists. Circle coincides with the square means saddle point exists. This corresponds to the second strategy of the player B. This corresponds to the third strategy of the player A. తీసేసుకుంటా ఏ స్ట్రాటజీకి తీసేసుకుని గుర్తుపెట్టుకోవాలి. సో ప్లేయర్ ఏకి థర్డ్ స్ట్రాటజీకి ఇది వస్తుంది, ప్లేయర్ బికి సెకండ్ స్ట్రాటజీకి ఇది వస్తుంది, ఇంటర్సెక్షన్. సో బెస్ట్ ప్యూర్ స్ట్రాటజీ ఫర్ ద ప్లేయర్ ఏ, థర్డ్ స్ట్రాటజీ. బెస్ట్ ప్యూర్ స్ట్రాటజీ ఫర్ ద ప్లేయర్ బి, కన్ఫ్యూషన్ అవసరం లేదు. He will never choose other strategies apart from third. He will never choose other strategies apart from second. వీడికి వన్ బెస్ట్ ప్యూర్ స్ట్రాటజీ ఉంది, వీడికి వన్ బెస్ట్ స్ట్రాటజీ ప్యూర్ స్ట్రాటజీ ఉంది, సెకండ్ స్ట్రాటజీ. Value of the game equal to 5. This is how saddle point will be found out by applying minimax maximini criterion. So remember, if any big size payoff matrix is given, applying the rules of dominance, you need to reduce the game size to the dam minimum and then find whether the minimax is equal to maximini, saddle point exists for the game, whether it is a pure strategy game or not. If it is not a pure strategy game, then depending upon the size of the matrix, by applying rules of dominance, you will be reducing it to the dam minimum size. If the minimum size that is reduced is equal to 2 by 2, you can go for arithmetic method. One method is there, provided if it's not a pure strategy game. If it is a pure strategy game, solution is already obtained. This is the solution in case of pure strategy game. If at all there is no saddle point for the game, there is no solution is not obtained there. That is called a mixed strategy game. Mixed strategy game అయి ఉంటుంది. దాన్ని కనుక్కోవాలంటే, సొల్యూషన్ కనుక్కోవాలంటే, you need to apply the other methods. When the game size, payoff matrix is 2 by 2 size, go for arithmetic method. If it is 2 by n, 2 by n అంటే ఏమి, 2 rows n columns అయితే graphical method, or m rows and 2 columns అయితే it is called, that is also a graphical method. You can employ graphical method to solve such games. 2 rows n కాలమ్స్ ఉండదు, ఎక్కువ కాలమ్స్ ఉంటుంది. అందుకంటే you cannot reduce by applying rules of dominance. If the size of the matrix is that way, you can apply graphical method. Similarly, m rows and 2 columns only. Then also more than two rows ఉంటాయి, 2 columns. Then also graphical method. That is not ఇది కాదు, if 2 by 2 size కాదు, 2 by n కాదు, if the reducer size of the matrix is not equal to 2 by 2, is not equal to 2 by n, is not equal to m by 2, some smart size is there. Say 3 by 3 game, 3 by 3, 3 rows, 3 columns. You cannot reduce it further, say, and there is no saddle point. Then you have to go for the algebraic method or linear programming method. I repeat once again. If at all payoff matrix given is large, apply the rules of dominance, reduce it to the minimum size. Then apply the minimax maximini criterion. Find out if at all the saddle point exists for the game. The saddle point exists for the game, solution is there. Value of the game is the saddle point. Corresponding strategies will be the best strategies for the player. One single best strategy for the player A, one single best strategy for the player B. If at all the saddle point is not obtained, if there is no saddle point for the game, such games are called mixed strategy games. Solving mixed strategy games is possible by applying special methods. If the game size, reduced size is 2 by 2, no saddle point, arithmetic method. If the game size is 2 rows n columns, no saddle point for the game, then go for graphical method. If the game size is m rows and 2 columns, if there is no saddle point, go for graphical method. Odd size is not conforming to any of these sizes, not 2 by 2 size, not 2 by n, not m by 2. Say 3 by 3 or more than 3 by 3. Then go for algebraic method or linear programming method. These are the methods available for solving the mixed strategy games. Okay. The next session will go for the solution methods of the mixed strategy game.